Good evening, everyone. This is Unit 2 of IAL Chemistry, June 2015. In the first question, a flame test was carried out onto a mixture of magnesium chloride. Magnesium does not give a characteristic flame color, and on potassium chloride. So, potassium is lilac. The flame color observed. So, this one we don't observe any color. This one it will be a lilac. So, combination it will be a lilac. For question 2, the equation for the reaction of lithium with excess of water. Group 1 are known as alkali metals. Why we call alkali metal? Because when they react with water, this result in a formation of alkali. So when you check equation C and D, lithium hydroxide is produced. The balance equation, when you check here, the equation is balanced, but the state of lithium hydroxide, it is written solid. But when we add lithium metal to water, it results in a formation of aqueous lithium hydroxide or alkali. That's why D is the right answer. For question 3, solid sodium is reacted with chlorine and a product of this reaction is added to water. So when a solid sodium is reacted with chlorine, so it will form sodium chloride, and then sodium chloride is dissolved in water, so it will form aqueous sodium chloride. So what we will observe, group 1, 2, 3, their soluble salts are colorless. So we'll observe a colorless solution. Question 4. Solid barium hydroxide and barium sulfates are similar. Group 1, 2, 3, their compounds are white solid. So barium hydroxide will be white solid and barium sulfate is also white solid. So they will have the same color. pH of the solution, this will be barium hydroxide alkaline, barium sulfate is insoluble. Reaction with hydrochloric acid, barium hydroxide will react, but barium sulfate will not. And solubility in water, barium sulfate is insoluble, and solubility of hydroxide increases as we go down the group. For question 5, the solids magnesium carbonate and magnesium nitrate are identical in a gas release on heating. The gas which metal carbonate release on heating, that's carbon dioxide, and this will be nitrogen dioxide. So this is not right. The reaction with hydrochloric acid, when they react with hydrochloric acid, it will give salt water and carbon dioxide, but this will not form the same result. A solid product of their thermal decomposition, when we heat them, it will produce magnesium oxide plus carbon dioxide. This will produce magnesium oxide plus nitrogen dioxide plus oxygen. So both are giving the same product. That's why C is the right answer. All nitrates are soluble, so their solubilities are not same because magnesium carbonate will be insoluble. In question 6, the oxidation number of sulfur in potassium aluminum sulfate. So we have KAlSO4 in a bracket and 2. Potassium is group 1, and so this will be plus 1. Aluminum is group 3 plus 3, and this overall it should be, because sulfate, the valency of a sulfate ion is -2. When we write, because KAl, this will be overall plus 4 and SO4 with a -2. When we simplify, 2 is to 1, and the formula will be KAl SO4 in a bracket 2. So SO4 overall valency is -2. So we need the oxidation number of a sulfur. How we will work out oxidation number of sulfur? So each oxygen is -2, so 4 oxygen will be -8, so sulfur should be +6, so that overall charge on the sulfate ion will be -2. That's why C is the right answer. Which of the following equation represent the halogen displaces that can occur? Always a more reactive halogen can displace less reactive halogen, so fluorine is more reactive than chlorine, chlorine is more reactive than bromine, and bromine is more reactive than iodine. So when we check potassium bromide with iodine, there will be no reaction. Potassium chloride with bromine, no reaction. Potassium fluoride with chlorine, no reaction. Potassium bromide with chlorine, there will be a reaction. So that's why D is the right answer. For question 8, we have a silver halide which is insoluble in water but soluble in dilute aqueous ammonia. And this one, silver chloride, it is soluble in both dilute as well as concentrated aqueous ammonia. This one is insoluble in dilute but soluble in concentrated aqueous ammonia. This one is insoluble. This one is also insoluble, both dilute and aqueous. So A is the right answer because they are asking which one is soluble in dilute aqueous ammonia. So silver chloride is soluble in dilute aqueous ammonia. For question 9, consider the following equilibria in which of the following both the stated change increases the amount of a product. So the forward reaction is exothermic. So if a forward reaction is exothermic, for forward reaction it preferred low temperature, means we should decrease the temperature. So we should decrease the temperature, and about the number of the moles of gas, 2 moles of a gas on the reactant side and 1 mole of a gas in the product side. So increase in pressure shift the equilibrium towards size where number of moles are less. So we should increase the pressure and we should decrease the temperature. So B is the right answer. For question 10, consider the following simplified equilibria for an indicator. Addition of few drops of sodium carbonate. So when we add sodium carbonate, this proton will react with sodium carbonate and amount of product will decrease. So when amount of product decrease, equilibrium will shift towards right hand side. So it will appear as equilibrium shifted towards right hand side, the mixture will turn more purple because the acid or the proton react with sodium carbonate. So amount of proton or hydrogen ion in the solution decreases. That's why the equilibrium shifted towards the right hand side. Which of the following species has the smallest bond angle? So when we write for carbon dioxide a linear structure, so bond angle is 180. When we write for water, 2 bond pair and 2 lone pair, bond angle is 104. Sulfur trioxide, trigonal with a bond angle of 120, and hydroxonium, 1 bond pair, 1 lone pair, and 3 bond pairs are there. One of them is dative, so bond angle will be 107.5. So which one is having the smallest bond angle? Water, which is having a bent structure. Which of the following bond is likely to be most polar? Most polar means there is a greater difference in reactivity. When we move across the period, the electronegativity increase. When we go down, electronegativity decreases. So hydrogen on the left hand side and fluorine on the right hand side, they will have the maximum difference. That's why highest bond polarity or the most polar bond will be there between H and F. Question 13. A lump of malachite CuCO3.CuOH2 react with 40 cm cube of 0.5 mole per dm cube hydrochloric acid. The rate of a reaction increase by increasing pressure. Here we are reacting a solid, so increasing pressure does not have significant effect. Solid and aqueous solution is there. Crushing the malachite, the ore, increases the surface area, so rate of the reaction will also increase. Replacing the acid with 80 cm cube of 0.25. So if we decrease the concentration and increase the volume, the rate will decrease. Using magnetic stirring. So if we use a magnetic stirring, we don't have a magnetic material here, so it does not affect the particles or the rate of the reaction. Consider the following reaction carried out with 0.1 grams of magnesium ribbon with excess of hydrochloric acid. Which method should be used to follow the rate of the reaction? So here a gas is given off. So measure the pH of a solution using a pH meter. Excess of hydrochloric acid is there, so there will be no significant effect. Measure the color change here. Aqueous solution colorless, group 2 salt solution colorless. Use volume of a gas. We can measure the volume of a gas. Hydrogen gas is there, so we'll measure the rate of reaction. Measure the mass of mixture using a balance. So if we measure the mass of the mixture, but the mass of the mixture, if we do not allow the gas to escape, the mass of the mixture won't change. And two decimal places, it will not be accurate. Why? Because very small quantity of hydrogen is given off. That's why C is the valid answer. Question 15. The graph is shown for concentration of a product and time in the reaction. The change in concentration of a product with time shown by the dashed line X. Which of the line from A to D show adding a catalyst? So increasing the catalyst will increase the rate of the reaction, but the final product will be same. So B is the right answer. D is white is wrong because the final product has changed. C white is wrong because the rate of the reaction is decreased, but catalyst increases the rate. And why A is wrong because it alters the amount of product as well. It only affects the rate of the reaction. For question 16, bromoethane react with concentrated alcoholic ammonia to produce ethylamine. However, this reaction mixture ethylamine form further react with bromomethane to produce diethylamine. This further reaction of ethylamine can be limited. So how we can limit this? So if we use excess of ammonia, because first what is happening? A bromomethane is there, C2H5Br reacting with ammonia. This result in a formation of C2H5NH2 plus HBr. And this C2H5NH2 further react with another bromoethane, and that will result C2H5 bracket 2NH and plus HBr will be there. So basically we want to limit this second reaction. So how we can limit this second reaction? So if you use excess of ammonia, that every time ammonia is reacting with bromoethane, so we will limit the second reaction. Question 17. In the preparation of 1 bromobutane from butane 1-ol, it is preferred to react sodium bromide with 50% sulfuric acid rather than concentrated. What is the reason for that? Because if we use concentrated sulfuric acid, then when hydrogen bromide is produced, that will further react with sulfuric acid and it will reduce the sulfur to lower oxidation number and oxidize the bromide ion into bromine molecule. So it oxidizes HBr, which is produced in the first stage, because first what happened when NaBr is reacted with H2SO4, this will produce sodium hydrogen sulfate plus hydrogen bromide. And this HBr, if we have concentrated sulfuric acid, will further react with sulfuric acid and it will produce bromine molecule and produce products of sulfur of lower oxidation state such as sulfur dioxide or sulfur molecule. So it oxidizes HBr to bromine. That's why we are not using concentrated sulfuric acid. Question 18. The reaction between aqueous hydroxide ion and halogen alkane to produce alcohol classified as. So how we classify this reaction? If we have halogen alkane, this is partial positive, partial negative, and OH is there, that will attack. So it is attacking on a positive center and substitution reaction occur, OH attached. So it's a nucleophilic substitution reaction. And what kind of bond breaking will occur? It's a heterolytic bond breaking because it will form a carbon cation as the halogen leave. So C is the right answer. Which of the following has the longest bond length? Longest bond length you can work out by number of the shells available to form a bond. Chlorine first shell 2 electrons, second shell 8, third shell 7. And another chlorine first shell 2, second shell 8, and third shell 7. So 3 shells they have. But when H and Cl are there, this will have 3 shells but hydrogen having only 1. Oxygen only 2 shells and nitrogen also 2 shells. So which is having the higher greater difference in the between the center of the nucleus, half of intermolecular distance between center of the two nuclei. That's called a bond length. So chlorine will have the longest bond length. Question 20. Maxwell-Boltzmann distribution graph can be used to illustrate the effect of increasing temperature on rate of chemical reaction. Which area of a graph indicate increase in number of the molecule? So increase in number of the molecule, when we increase the temperature, so increasing the temperature shift the peak towards right hand side and the height of the peak decrease. So this is the increase in the number of molecule that will react at higher temperature. So C is the right answer. So this was June 2015, Unit 2, IAL Chemistry.